Thunderbird operates out of UBC Mining, where considerable research is carried out for the mining industry on telerobotic underground vehicles, so extending our work to the Grand Challenge was not a major change in focus. We are using the Bumblebee stereo vision system from a local supplier, Point Grey Research, and from SICK Instruments we have an LMS 291 LiDAR device for obstacle detection. Yeah, and how long did it take you to get this up and running?
A few hours, spent pretty much all night, Friday night.
They've been working for 24 hours straight. Team Thunderbird needs to get their Jeep on the road and running by the end of the day. If they don't make it, they may be kissing $2 million in prize money goodbye.
$2 million US buys a lot of good Canadian beer.
Team Thunderbird is working with a substantially smaller budget.
I think the bolts cross-threaded or something. No, Diego, we got work to do.
Their high-tech equipment includes a 10-speed sprocket and derailleur.
We have a computer on board that basically mimics how we think as human beings as we drive a car, and it will have to do this without any human intervention whatsoever.
The team will run the truck by remote control.
There's 2 channels. Throttle is when you press it up.
The next step will be to install the computer brain
and we set the position manually
to replace the human operator. Team Thunderbird's approach is different than other teams. Instead of building an autonomous vehicle, they've decided to focus only on the driver.
We can take this out, throw it in a Ford Explorer or Chevy Suburban, whatever vehicle you want. It's a matter of 4 bolts and taking out the driver's seat and dropping this one in.
We're running short for time.
The team has been plagued for days with faulty wiring in their command system. Eventually, the bug is traced to loose wire. The light's starting to fade. Steve decides it's time to give it a try. It's time to test, but the steering control is working, but the brake and gas pedals aren't. For the next hour, they troubleshoot, and the sun slips from the sky.
Let go for a second.
Yeah.
Well, why don't we run this wire straight to the positive?
When they do find the problem, it turns out it's those loose wires again. Steve makes the final checks. The good news is Steve installed a kill switch a few days ago.
I reached for the emergency stop right off the bat, so I definitely knew our calibration was off.
It's a scare for the team, a lesson in rushing things.
We've managed to make the largest remote control car that any of us have ever played with.
For now, Team Thunderbird heads back to the lab.
Back at the lab, we focus on a brake actuator, and we construct a PCB board to replace the flaky wiring that's given us so much trouble.
This is the interface board, which takes in all the remote control signals. It's a very clean circuit.
Back to the field. Here we see the team manually testing the e-stop system. The lessons from our first test have been well learned, and our approach is now slow and steady. Our tests were conducted at low speed using a script for each run. First, a controlled stop. Next, a right turn and stop. Finally, a left turn was executed. As the human operator became more skillful in using the controller, he was permitted to circle the parking lot. This circling action was continued for some time to build up considerable videotape that will help us develop safety procedures for our future test work, particularly those tests that involve our autonomous system. As a final evaluation of our hardware system, a limited trial was run on object avoidance. This test demonstrates the difficulties that a novice tele-remote driver faces in operating a vehicle to avoid obstacles. Note the difficulty in setup, the difficulty in getting the vehicle around the pylons, and the difficulty in coming through without hitting a pylon. Eventually an operator can become quite skilled, but initially it takes a lot of effort and a lot of training to achieve success. But our software group has the answer. Using a simulator, they've developed a fully autonomous prototype to avoid obstacles. No instruments mounted on the Jeep. We can study the best location for these instruments on snowstorm in this virtual environment.
Working on the fuzzy logic here. Oh, is that the part that comes out of the presidential module?
Actually, the presidential module here issues the executive command.
It's the generals that do the fuzzy thinking.
Our software mimics a military hierarchy, with policies becoming linguistic scenarios leading to fuzzy strategies that require defuzzification for implementation by the troops who operate the vehicle or feed data back to the intelligent modules. There are 6 features of our entry that make Team Thunderbird unique from all other teams. It is our firm belief that Team Thunderbird can win this race because of our unique hardware and software approach. So get that check ready for Team Thunderbird because we intend to win the DARPA Grand Challenge.